Good morning, students. In the previous class, we discussed about the actual nuclear charge. What is meant by actual nuclear charge, effective nuclear charge, and the screening effect and the atomic radius in the periodic. How it is variation of atomic radius and ionic radius in the periodic table. And also we are discussed about the isoelectronic species. This we are discussed in the previous class. In this class, we are going to be discussing about the ionization enthalpy or ionization energy. Ionization enthalpy is also called as ionization energy. Then, what is meant by ionization energy? Means the amount of energy required to remove the electron from the outermost shell of the neutral gaseous atom. Neutral gaseous atom is called as ionization energy. Ionization andre the energy ಎಷ್ಟು ಬೇಕು ಯಾವುದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡೋಕ್ಕೆ ಆಲ್ಮೋಸ್ಟ್ ಶೆಲ್ ಇಂದ the neutral gaseous atom ಇಂದ neutral gaseous atom ಅಲ್ಲಿರುವಂತ ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡೋಕ್ಕೆ ಎನರ್ಜಿ ಎಷ್ಟು ಬೇಕು ಅದನ್ನು ನಾವು ಏನಂತ ಕರೀತೀವಿ that we call as ionization energy or ionization enthalpy ಅಂತ ಕರೀತೀವಿ. that we call as enthalpy means the amount of energy required to remove the electron from the outermost shell of neutral gaseous atom. Neutral gaseous atom. In this, now we are going to be discussing about the first ionization energy. That is the first ionization energy. Ionization energy means the same definition we can give. What the definition we are given for the ionization energy, that also called as the first ionization energy means the amount of energy required to remove the electron from the outermost shell of the neutral gaseous atom is called as the first ionization energy. It is also called as ionization enthalpy, ionization energy is also called as ionization enthalpy and ionization energy means if the removal of one electron from the neutral gaseous atom is going to form a cation. It is going to become a positive ion. Removal of one electron is forms a positive ion. Then plus one electron. ಇಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ವಿ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ್ಯೂಟ್ರಲ್ ಗ್ಯಾಸಿಯಸ್ ಆಟಮ್ ಇಂದ this we call as the neutral gaseous atom. From this we are removing the one electron. That energy required for this process we call as a first ionization energy. The energy required for this process we call as a first ionization energy. This next we go for the second ionization energy. The second, that is the second ionization energy. Second ionization energy. This second ionization energy, the amount of energy required to remove the electron from that is unipositive ion is called as a second ionization energy. Means the unipositive ion ಅಲ್ಲಿ electron remove ಮಾಡಕ್ಕೆ ಬೇಕಾಗಿರುವಂತ ಎನರ್ಜಿನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ second ionization energy ಅಂತ ಕರಿತೀವಿ. we call as a second ionization. ಆಲ್ರೆಡಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗಿದೆ, ಅದರ ಜೊತೆಗೆ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ is going to form the dipositive ion. Then dipositive ion, the removal of the one electron. Like this only we will go for the third ionization energy. Third ionization energy. When it goes to the third ionization energy, that is the amount of energy required to remove the electron from the dipositive ion. That is dipositive ion is called as a third ionization energy. Is called as a third ionization energy. That is a unique dipositive ion in the ionization energy. This we call as in this dipositive ion, removal of the electron from this, we are going to get the tripositive ion. Then this energy we call it as a third ionization energy. Means third ionization energy means the amount of energy required to remove the electron from the dipositive ion. ಅಂದ್ರೆ dipositive ion ಇಂದ electron remove ಮಾಡಕ್ಕೆ ಬೇಕಾಗಿರುವಂತ ಎನರ್ಜಿನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ third ionization energy ಅಂತ ಕರಿತೀವಿ. This ionization energy, now we know that what is meant by ionization energy ಅಂದ್ರೆ ಏನು ಗೊತ್ತು, ಮತ್ತೆ first ionization ಅಂದ್ರೆ ಏನು ಗೊತ್ತು, second ionization energy, third ionization energy ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತು. Now I will say that the second ionization energy, the second ionization energy is greater than the first ionization energy. Why it is so many times asked in the examination? Why the second ionization energy is greater than the first ionization energy? Two reasons we can give. The first reason is the removal of electron from the neutral gaseous atom, that it attains the atom, that is the positive atom, is going to be the electronic configuration of that atom or ion attains the nearest noble gas electronic configuration. Therefore, it requires the more energy to remove the electron again. ಅಂದ್ರೆ ಫಸ್ಟ್ ಏನಾಗಿರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಾದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಆಫ್ಟರ್ ಫಸ್ಟ್ ionization energy ಅಂದ್ರೆ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ನಾವು ರಿಮೂವ್ ಮಾಡೋದು ನ್ಯೂಟ್ರಲ್ ಗ್ಯಾಸಿಯಸ್ ಆಟಮ್ ಇಂದ ರಿಮೂವ್ ಮಾಡ್ತೀವಿ. ಆವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅದು ಯೂನಿಪಾಸಿಟಿವ್ ಅಯಾನ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತಲ್ಲ, ಅದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಇಟ್ is going to be attains the nearest noble gas electronic configuration ಗೆ ಬರುತ್ತೆ. Then it is difficult to remove the another electron, it needs the more energy. Difficult ಅನ್ನೋದಕ್ಕಿಂತ more, it requires the more energy. Therefore, the second ionization energy is greater than the first ionization energy. In other words, after the first ionization, the screening effect is going to be decreases. Effective nuclear charge is going to be increases. The effective nuclear charge increase ಆದರೆ the attraction between the nucleus and the outermost electrons is going to be increases. At that time, the removal of the electron from that electron is needs the more energy. That is the removal of the electron from the outermost shell. It needs the more energy. Why it needs the more energy? Because the force of attraction between the nucleus and the outermost electron is increases. ಅಂದ್ರೆ ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಬೈಂಡ್ ಆಗುತ್ತೆ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ outermost shell ಅಲ್ಲಿ ಇರುತ್ತೋ ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಕಡೆಯಿಂದ ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಬೈಂಡ್ ಆಗಿರುತ್ತೆ. ಯಾವಾಗ ಬೈಂಡ್ ಆಗಿರುತ್ತೋ ಅವಾಗ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಕ್ಕೆ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. Therefore only the second ionization energy is greater than the first ionization energy. Then you can give the two reasons. One is it attains the nearest noble gas configuration after first ionization, and after the first ionization the screening effect decreases, effective nuclear charge increases. Therefore it needs the more energy to remove the electron from the outermost shell. This about the that is the ionization energy. Then now we will discuss about the variation. That is a variation of ionization energy in the periodic table. Yeah, now we are going to be discussing about the along the period. First we are going to be discussing about the how the ionization energy varies along the period. Along the period. When it comes to the along a period, the atomic size is going to be decreases. Atomic size is going to be decreases. The screening effect is going to be decreases. The screening effect is going to be decreases. The effective nuclear charge is going to be increases. Atomic size along the period already we know, previous class we discussed. Atomic size is going to be decreases. At that time, the screening effect is going to be decreases. When the atomic size is going to be decreases, the screening effect is also decreases. At that time, the effective nuclear charge is going to be increases. When it is effective nuclear charge is increases, at that time it needs the more energy to remove the electron from the outermost shell. That's why only the ionization energy, that is ionization energy is going to be increases. Ionization energy is going to be increases. This about the along a period, variation of ionization energy along a period. Means finally we can give the one statement, the along a period the ionization energy is going to be increases. Ionization energy is going to be increases. Then along down a group. It is down the group. Here the atomic size is going to be increases. Atomic size is increases. The screening effect is going to be increases. Screening effect is going to be increases. The effective nuclear charge is going to be decreases. The effective nuclear charge is going to be decreases. Therefore, when the effective nuclear charge is going to be decreases, less energy is enough to remove the electron from the outermost shell. Therefore, the ionization energy is going to be decreases. Ionization energy is going to be decreases down the group. In final statement in the examination, maybe they are going to ask about the variation of the ionization energy along a period down the group. Along the period it is going to be increases, down the group it is going to be decreases. This is about the variation of the ionization energy. Variation of the ionization energy along the, that is along the along a period down the group. The next we are going to be discussing about the electron gain enthalpy. Electron gain enthalpy and electronegativity. We will discuss about the electronegativity. Now we will discuss about the electron gain enthalpy. Gain enthalpy. Yeah, enthalpy is nothing but energy. Enthalpy is nothing but energy. Means this we are going to be represented by delta EGH. This we are going to represent by delta EGH. Means the electron gain enthalpy. What is meant by electron gain enthalpy? Here, the electron gain enthalpy means the amount of energy released. Amount of energy is released when an electron is added to the neutral gaseous atom. To form a negative ion. ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಅಯಾನ್ ಫಾರ್ಮೇಷನ್ ಆಗಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ನ್ಯೂಟ್ರಲ್ ಗ್ಯಾಷಿಯಸ್ ಆಟಮ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡ್ತೀವಿ. ಅವಾಗ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುತ್ತಲ್ವಾ, ಆ ಎನರ್ಜಿನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ. Electron gain enthalpy. Here, if you are going to be taken that this is the neutral gaseous atom. Neutral gaseous atom. The addition of the energy released, the addition of electron to the neutral gaseous atom to form a negative ion. That we called as that is electron gain enthalpy. Electron gain ಅಂದ್ರೆ ನೋಡಲೇ ಇದೆ, electron gain ಅಂದ್ರೆ electron ಆಡ್ ಮಾಡ್ತೀವಿ, ಆವಾಗ ರಿಲೀಸ್ ಆಗುವಂತ ಎನರ್ಜಿನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ that we called as electron gain enthalpy. If you are going to be taken the fluorine, that is the fluorine gaseous atom we are going to be taken. For the addition of one electron to this, at that time it is going to be formed the fluoride ion. There is at that time delta EGH is equal to minus 328 kilojoule per mole. This much of energy is going to be released during the formation of fluoride ion. That we call as that is electron gain enthalpy. Like this only, if you are going to be taken the chlorine. For chlorine, neutral gaseous atom, the addition of the one electron to this, at that time is going to be formed that chloride ion. At that time it is going to be formed that delta EGH is equal to minus 349 kilojoule per mole. This much of energy is going to be released. Therefore, that is addition of the electron to form a neutral to form a negative ion. The energy released is called as that is electron gain enthalpy. Now we will discuss about the variation of that is electron gain enthalpy in the periodic table. First, electron gain enthalpy. We should be remember this formula. Electron gain enthalpy is equal to 1 by atomic size. We know that. Now along a period. If you are going to be taken along a period, the atomic size decrease ಆದರೆ electron gain enthalpy increase ಆಗುತ್ತೆ. Vice versa. This electron gain enthalpy and atomic size. Atomic size ಏನಾಗುತ್ತೆ? The atomic size along a period is going to be decreases. Therefore, the electron gain enthalpy is going to be increases. This is a vice versa. Therefore, that is the atomic size is going to be decreases. Therefore, the electron gain enthalpy is going to be increases. Then down the group. Now the group, what happens? The atomic size is going to be increases. Atomic size is going to be increases. Therefore, the electron gain enthalpy is going to be decreases. Vice versa. If atomic size increase ಆದರೆ electron gain enthalpy decrease ಆಗುತ್ತೆ. Atomic size decrease ಆದರೆ electron gain enthalpy is going to be increases. Means vice versa. ಒಂದು decrease ಆದರೆ ಇನ್ನೊಂದು increase ಆಗುತ್ತೆ. Then this about the electron gain enthalpy. Next we will discuss about the electron activity. This is the last topic in this chapter. Electronegativity is the last topic in chapter. Electronegativity means that is the tendency of an atom. Tendency of an atom in a chemical compound. In a chemical compound, it attracts the shape pair of electron towards it. Towards it is called as a electronegativity. Electronegativity means it can be defined as the tendency of an atom in a neutral gaseous, that is tendency of an atom in a chemical compound. The tendency of an atom in a chemical compound, it attracts the shape pair of electrons. When the compound alli, when the atom shape pair of electrons na attract madidre, ಆ tendency na ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ electronegativity ಅಂತ ಕರಿತೀವಿ. This electronegativity also, it is a vice versa of the atomic size. That is the electronegativity is equal to 1 by atomic size. 1 by atomic size means first we are going to discussing about the along a period. Along the period what happen? The atomic size is going to be decreases. Atomic size is going to be decreases. Electronegativity is going to be increases. ಅಂದ್ರೆ ಒಂದು increase ಆದರೆ ಇನ್ನೊಂದು decrease ಆಗುತ್ತೆ, ಇನ್ನೊಂದು decrease ಆದರೆ ಇನ್ನೊಂದು increase ಆಗುತ್ತೆ. Then down the road, this such the atomic size is going to be increases. Down the group, atomic size is going to be increases. Electronegativity is going to be decreases. Is going to be decreases. Means vice versa. Andre atomic size decrease ಆದರೆ electronegativity increase ಆಗುತ್ತೆ. Atomic size increase ಆದರೆ atomic the electronegativity is going to be decreases. This about the electron gain enthalpy and the electronegativity. This about the completion of the chapter, that is the classification of element and periodicity in the properties.